Well, here we are in the lab again, and I'm still waiting for the boards to come in from PCBWay. It's going to be a little bit longer than usual because it's Chinese New Year. They put a notice up there. But it should be probably done in the manufacturing today. It's in production, or I should say they are in production. And I ordered the parts from Mauser because DigiKey didn't have the digital potentiometer. And then if you break up the order, then you got to pay postage, and just one part from Mauser's like you're going to pay postage on that. So Mauser had everything, so I just did an order from Mauser. It should be here in a day or two. And so I was gonna do a thing about where I showed you how I found what parts to use and stuff, and it's probably not that big of a thing, you know. It's what I did because I knew I was going to use a microchip microprocessor. So I went to Microchip's homepage, and then you can do the product selector, and it's like what they call a parametric search. So you just select all the features that you want, and it gives you a list of products that they have that meets that requirement. So basically, I wanted an analog to digital converter, which almost all microcontrollers, at least for Microchip, have one in it. Some are 10-bit and some are 12-bit. And I wanted a DAC. So not all microcontrollers have DACs. That's a less popular item. So then I wanted to have some kind of comparators or something, and I listed a few things, and surprisingly what popped up among the list, there was a list about 5 different microcontrollers, and the microcontroller that I actually use for my motion board popped up, so I'm like, hey, I'm going to use that because I already have it, I already know about it, and we'll just stick that on there. It's like a $5 microcontroller, so it's not that big a deal. And so then for like trying to find the digital potentiometer, I just asked ChatGPT. I'm like, yeah, I need something that does this and that, and it gave me a list of ways to do it and things. So I looked at it and figured out which one I like best, and it helps you out a lot on stuff. So, and like I said before, don't be afraid to ask ChatGPT. I mean, it might not give you the 100% answer you want, but it'll send you in the right direction, give you something to think about. It's like having that assistant roaming around the lab that you can ask questions to and talk to and stuff. It's good. I like it. What else? Well, while I'm waiting for parts and stuff, I'm caught up on the circuit board stuff. So, oh yeah, I did add one thing. I put mainbrain Gerber files and the I/O card Gerber files up on the public directory, and I shared the Fusion files, the project, on there. The way Fusion works, you can't like try it out on another computer like under a different username or something, so I can see what you guys see. You only get one user and one computer, and that's all Fusion gives you for free unless you want to buy subscriptions. And so you'll just have to let me know in the comments if you can't see those, if you load them up in Fusion. It's just like one file, Fusion file. But yeah, we'll see how that works. It's hard to share. I wanted to share publicly the project, but on the free account you can't do that too much. So, and you can invite people through a link, but it doesn't actually give you the project files where you guys can pull it into your Fusion and use them. So that's my goal. I want you guys to be able to pull in everything so you can change it, modify it, see how it works. And I don't know if we're going to be able to do that with Fusion. We'll just have to see what comes in the future. But at least you can take the Gerbers and you can submit it to the PCB shop and have the boards made, and you can build one. So after the I/O board thing, I'm gonna do a main brain build. So we'll take a blank board and we'll get the parts and we'll solder it on there, because I need another main brain anyway. So, and then you guys, if you want, you can build the whole project, because main brain is really a pretty good controller. And then right now, since I'm waiting for parts and I'm caught up on the PCB, there's code to write, and I'm never caught up on the code. So I'm going to show you a little bit of code and some how I'm doing some of the graphics, because when you write driver code, it's a whole different thing than when you write a user interface code. That's a difference between day and night. So I'm going to show you a little bit of my interface. And see, with main brain, you have three types of programming you have to do. You have to do the driver programming for the chips, and you have to do the user interface programming, and then you have Windows app that controls main brain, and you have to write some Windows code too. And we'll cover all that eventually. One of these days we'll get to everything. But right now I just want to show you what I'm doing in my downtime, so to speak. I have on my motion, I'm in the late testing phase of main brain and the early testing phases of my motion board, and maybe even the mid. You might even say the mid testing range of the motion board. So I'm going to show you a few things and a few shots of the machine shop. I haven't done any machine shop stuff because it's too cold in the machine shop. I don't have heat in there, and it's been really cold here. So we have a warm spell every year in February, so I ran out and I made a couple parts, and I need to finish them, and I'll take you a quick trip through that and show you a couple things I'm doing, and we'll call this a good supplemental video. Okay, so this is just a supplemental video, so we're not going to get overly professional about the video here. So this is what my motion board controls. This is a test fixture, but it's also going to be part of a robot. So I want to try to make some limbs move. It's a hard thing to do, but this is going to be one of the driving engines of a limb, I hope. So basically, it consists of a motor, a BLDC motor, and then there's an encoder up here, and it just counts how many ticks. This one has 600 ticks for one rotation, and so with the gearing, it is equal to the motor. So whatever rotation the motor does, you get the same rotation out of the encoder, and there's 600, and that's a little too many. Maybe I might change that. And then there's like this cross shaft in here. This part of it isn't done yet, because right here the shaft comes out, and then we're going to have 2 planetary gear sets in there before it drives any actual part of the robot. So, because we need to gear it down, because limbs don't move the same as tires and stuff. It's a whole different thing. So basically it's what I need to do. I got this idler on here, and as you can see, it sticks out right here. It doesn't line with the belt. So we're going to go in and we're going to peel off right in here. We're going to peel off 3 millimeters off of this spindle right here. And then this, when I machined it, I made a small mistake in where I put the hole on the, I made a mistake on the on center measurement of the hole for the motor, so it threw off some of the dimension for this idler adjuster. So right here we're going to chop off a little bit so it doesn't stick out so far. And so then yesterday I made this shaft right here for the motor, and it sticks out, but it's stainless steel and it works really good. It's very concentric. I just did like maybe a thou too small, maybe even 2 thousandths too small. So it's a little bit sloppy, but we can deal with it on this one here. And so that's what we're going to do in the shop, in the machine shop. And now over here we have main brain, and the red board, orange board, it's red, I guess. The red board is the actual motion board. You can see a couple of jumpers here, so I got another revision to come out. And so on top, they're interfaced through the ribbon cable. You can see how that is. And then there's main brain sitting on top, and then we have the PIC kit 5 hooked up to program it. And so the way it works is you change the code, you have to download the code every time to main brain. It's not like a real-time thing. And so you do a lot of updates. I mean, hundreds and probably even thousands of updates programming it. So all right, so as far as the graphics I'm working on, I'm using my phone because the cam don't like the brightness of main brain. It really freaks it out. It makes it really dark. I even turned the screen brightness down. But anyway, so I struggled for a while to like, what do I show when it first boots up? I mean, what do I do? So I just, over time, I decided to just put on, they call it, the advertising people call it the splash logo. So that's what I call it. This is the splash logo here that pops up. And so if you touch the screen, then you get a menu. And that's the config menu. And so right now I just have, if you touch the screen here, then you get a display, a little display menu. And then if you hit OK, then it goes away. That's all I got right now. I just worked on that this morning. So that's another thing I do while I'm waiting for parts and boards and stuff. Catch up on that kind of stuff. Okay, so now we're going to take off the idler. There's just one screw back behind here. Out. We got to take the screw all the way out. Okay. And then the belt comes off. So we got to take this part off right here. And remember, I was saying we got to take 3 millimeters off of that. Okay. Then we come over here. We want to take this motor pulley off. That is the size. One set screw there. One set screw there. And that slides off. And then we got to make a bushing for this. take the place of these washers I have on there. And this shaft will slide right out. And then bearings, just like that. And then we're going to shorten that shaft. Alright, to the machine shop. Okay, so I guess I'm not ready to be filming in the machine shop because I had technical problems, so we'll have to get that set up for filming in the machine shop for later this year. Not too far along. So anyway, I shortened the shaft, so we'll slide that in from the back, and it goes up in there like that. Alright, and I didn't make a bushing yet, so we'll continue to use the two washers right there. Alright, and then I forgot to show you, right here is a magnet. I put a magnet in there, that's for over here. That's the index counter, Hall effect switch, and that goes on there like that. Looks like we did pretty good. So now we'll tighten that guy down right here. Just like that. One set screw. Two set screws. Alright. Looks like it rolls pretty smooth, but it could be, I can't tell. Could be optical illusion. Looks like my pulley is a little bit off center. But we can fix that. We can bore it out, ream it, and then put a new shaft, a little bigger shaft in it. We can do that if we have to. But it's working good right now. So then we got the belt goes on here like that. And then we shortened that by 3 millimeters. Try to show it so you can see it. Pulley gets pushed on there like that. Okay. And the screw goes in like that. And I didn't shorten the bar yet. So that goes on there like that. Tighten that board down like that. Okay. That's good. Alright. And that slides in there like that. Okay. And the screw goes in. Right there. Get it tightened down a little bit. Push it in. You don't want to push it in too tight, but you want the belt fairly tight. It's a timing belt, so you want a little bit tight. A little bit. Alright, that's pretty tight. Looks good. Alright. See if it works real fast. Looks like it's working good. All right. Well, there you go. That's what I do pretty much when I'm waiting for parts or something. The bulk of it, it takes time to design a circuit board and stuff, but the bulk of it is the software. You got to write a lot of code. You got to write the code for the chips and then the user interface and the Windows stuff, and everything has to work together, and it usually don't. And so, but it's multifaceted. It's mechanical, electrical, design, troubleshooting, wiping tears, all that stuff. Sometimes it's just tedious, you know. You got 300 traces to connect, and it's just tedious, but you got to get through it, and your reward is the working product when you're done. So anyway, we'll see you in the next video.